The Altux CT toolkit includes tuning parameters and advanced features for the professional inspection engineer. Part 3 of the Altux CT training series will show the advanced features of the conebeam GUI, which includes the menus, reconstruction parameters, and the Save Restore feature. As shown in Part 1, launch the conebeam tools plugin. Load in a settings file by selecting Input CT Data, and navigate to the file named precmotor1.nsipro. Select Open. First, we will cover the menu items in the GUI. Go to Preferences. User mode gives the user the choice to run in normal or expert mode. Normal mode enforces workflow, guiding the user through the sequential steps that are required to obtain a reconstruction. Expert mode is only recommended for experienced users and situations where the normal workflow has been previously completed. The user, for example, may wish to rerun the same dataset with modified parameters. Now, select Expert under User Mode. Go to Utilities. Click on Read Session Header File. A new window will appear. This window contains all pertinent information generated during the current session, including workflow status, directory information, and various parameters. The header reader window is automatically updated as the user steps through the workflow, making it useful for keeping track of completed steps and selections made by the user. A header file is created for each dataset that is run through the conebeam workflow. Altux CT also creates a copy of the header file in the Lickenbrock folder each time a settings file is read in. This file has the .log extension, is saved in text format, and can be useful for tracking workflow progress over time or over multiple sessions. Since these log files are small in size, they remain in the Lickenbrock directory until the user decides to delete them. Once you are done looking at the header file, click Finished. Now, go back to the Utilities menu. In Expert mode, an additional menu item, ROI Coordinates, will appear in the Utilities menu. When selected, a ROI Coordinates window will appear, allowing the user to manually enter ROI coordinates. These coordinates are normally set automatically in the Pre-Reconstruction tab using the View Select ROI button. When a ROI is selected, the coordinates are also recorded in the log files. GPU information opens a window that lists all GPUs installed on the computer and their current processing mode. Run GPU Optimization opens the dialog box that is also presented to the user when the conebeam application is first started up. This gives the user the choice to optimize GPU devices. Set GPUs to standard mode returns the GPUs to non-optimized conebeam operation. Generate XZ-ZY slices creates slice views of a reconstruction output in the XZ and ZY planes. When selected, the user will be prompted to select a directory containing the reconstruction output. Next, go to the Options menu. Detector gain calibration brings up an additional GUI for calibration of detector gain, offset, and defects. The advanced user can select which files get used for detector calibration and specify additional gain files. Reduced angle reconstruction allows the user to run FEMOS with a reduced number of projections. For example, if the user enters 2, then FEMOS reconstructions will be produced using every second projection. This can be used to decrease processing time, but will also lower the quality of the reconstruction. FDK cutoff frequency allows the user to adjust the cutoff frequency of the Hamming filter used in the FDK reconstruction algorithm. This value is bounded within the range from 0 to 1. Fast FDK scatter corrected is enabled by default. When enabled, angle reduction is implemented for n-1 iterations of FDK scatter-corrected algorithm, where n is the total number of outer FEMOS iterations. During the last outer iteration, all projection data is used. This method provides faster execution time without having much of an effect on the reconstruction output. When disabled, FDK scatter-corrected uses all projection data. FEMOS noise suppression is unchecked by default. When enabled, FEMOS runs with default noise suppression parameters. High scatter correction corrects the projections for scatter using a larger correction factor than the normal workflow. Use low resolution for larger voxel sizes decreases execution time by decreasing the resolution of the reconstruction when a larger voxel size is selected. Under the information panel of the conebeam GUI, the user can choose larger voxel sizes from a drop-down menu. This will provide significant speed-up by decreasing the resolution at which the reconstruction is performed. Go back to Options. The Save Results option allows the user to adjust how the data is written to file. By default, the conebeam software saves the results as XY slices only. However, the user can select Save All Slices to save results in all three plane views, XY, YZ, and XZ. Additionally, the user can choose to save FDK and FDK scatter-corrected results as signed 16-bit data. By default, the data is shifted and saved as unsigned 16-bit. In some cases, it might be beneficial to use signed data. The Advanced Noise Suppression option allows the user to adjust the noise suppression parameters. Note that the FEMOS noise suppression must be enabled in order to edit the parameters. Tuning alpha and gamma can improve results for some datasets. Finally, go to the Help menu. About opens the splash screen window providing conebeam version and copyright information. To close the splash screen, click the Close icon. Tutorial will open a new window with the current conebeam tutorial. Release Notes will open a new window with the release notes of the currently installed version. Next, make sure that Expert Mode is selected and go to the Reconstruction tab. Select the FEMOS button. You will notice the same slider bar as before for adjusting the trade-off between speed and quality. To the right of the slider bar, you will also see an additional panel with advanced features. Instead of adjusting the slider bar, one can manually tune these parameters to adjust the trade-off between speed and quality. The Outer Iterations box adjusts the number of outer FEMOS iterations. The View per Subset box adjusts the number of projections that are used in each FEMOS iteration. A smaller number of projections used in each subset will lead to better convergence rate for the reconstruction. This means that the contrast and resolution of the resulting reconstruction will be improved relative to a larger number of projections used in each subset, given the same number of FEMOS iterations. A larger number of projections used in each subset may provide lower noise in the reconstruction, but would require a higher number of FEMOS iterations to achieve the same contrast and resolution as with the lower number of projections used for each subset. It is suggested to use the default values of 2 FEMOS iterations with 2 projections for each subset. The remaining item in the Advanced Parameters panel is a current prototype algorithm that will be added to the software at a later time. The Session section gives the user options to save and restore partially or fully completed sessions. This allows the user to stop the workflow at any completed step, save it, and then resume processing at a later time where it was last left off. All session files are saved to the Lickenbrock folder with the .xml extension. Saved session files may be opened for reading, but should not be edited in order to prevent data corruption. Now, click on the Save button. A file dialog window will appear that lets the user save the current session. Name the file and click Save. Now, close the conebeam GUI and launch it again. Click on Restore. Select a session file that you saved. Notice the GUI is restored to the previously saved workflow status and settings. In Part 3 of the training series, we learned how to use the advanced features of the Altux CT software package. This concludes the Altux CT training series. If you have any questions, please contact customer support at support@lickenbrock.com.